There is a soil technique from Korea, developed over centuries and refined by one man starting in the 1960s, that can replace virtually all synthetic fertilizers, pesticides, and herbicides. It costs almost nothing, and it can be made in a backyard. The global fertilizer industry, a $200 billion market dominated by a handful of corporations, has zero incentive for anyone to know about it. It is called Korean natural farming, and its central secret is indigenous microorganisms, known as IMOs. The science is real, the results are documented, and the reason most people have never heard of it tells you everything about how modern agriculture actually works. Hankyu Cho was born in 1935 in Suwon, South Korea. He started farming at age 13. He attended Suwon Agricultural High School, but did not start until late because of the Korean War. He graduated at age 29. He refused to go to college because the academic farming methods did not match what he had learned from observing nature directly. In 1965, Cho traveled to Japan for 3 years and studied under 3 masters of natural farming, Miyozo Yamagishi, Kinshi Shibata, and Yasushi Oinue. When he returned to Korea, he did something no one else had done. He fused what he learned in Japan with traditional Korean fermentation techniques, the same principles behind kimchi, doenjang, and gochujang, and applied them to soil. He called it Korean natural farming. He opened the Natural Farming Life School and Research Farm in Gosan County in 1995. He spent the rest of his life traveling to over 30 countries, teaching this method. Farmers worldwide call him Master Cho. This is not some random internet hack. This is a systematized farming method, developed over 60 years by a man who dedicated his entire life to it, with documented results across dozens of countries. The core principle of Korean natural farming is disarmingly simple. Your soil already contains everything it needs to feed your plants. You just have to wake it up. Beneath every forest floor and every undisturbed meadow, there is a thriving ecosystem of bacteria, fungi, nematodes, and protozoa, collectively called indigenous microorganisms. A healthy rhizosphere, the zone around plant roots, contains roughly 7 million microorganisms per hectare. These organisms contain approximately 70 kilograms of carbon and 11 kilograms of nitrogen, roughly the same amount of nitrogen farmers typically apply as synthetic fertilizer. The technique involves collecting these organisms from the leaf litter of a healthy, undisturbed forest floor near your farm, then culturing and multiplying them through a series of fermentation steps and reintroducing them into garden or farm soil. Lactic acid bacteria reproduce at 2.5 times 10 to the 11th per day at 25 degrees Celsius, improving soil ventilation and promoting rapid growth. But the real game changer is mycorrhizal fungi. These organisms extend root systems by thousands of times, convert soil nutrients into plant-available forms, sequester carbon, and produce glomalin, which gives soil its structure and water-holding capacity. Miles of mycorrhizae can exist in a single ounce of healthy soil. Bacillus subtilis, photosynthetic bacteria, yeast, and beneficial nematodes all play critical roles in nutrient cycling and decomposition. A study published in 2019 in the journal Sustainability by Liao and colleagues found that long-term natural farming significantly improved soil quality, increased microbial abundance, and enhanced microbial diversity compared to conventional farming. The University of Hawaii published multiple studies confirming the presence and activity of phosphorus-solubilizing and nitrogen-fixing bacteria in soils treated with Korean natural farming methods. The whole process takes about 3 to 4 weeks and costs almost nothing. Step 1 is IMO1, microorganism recruitment. Cook plain white rice with no seasoning. Place it in a wooden or bamboo box. Cover it with breathable paper and bury it in the leaf litter of a nearby healthy forest. After 3 to 5 days, the rice will be covered in white fungal mycelium. These are the local indigenous microorganisms already adapted to your climate, your soil, and your ecosystem. Step 2 is IMO2, nourishment. Mix the colonized rice with an equal weight of brown sugar or jaggery. The sugar feeds the microbes and preserves them, creating a shelf-stable starter culture that can be stored for months. Step 3 is IMO3, expansion. Mix IMO2 into rice bran or wheat mill run, moisten it to about 65%, and let it ferment in a pile for 5 to 7 days, turning occasionally. The microbial population explodes. Step 4 is IMO4, soil integration. Combine IMO3 with garden or farm soil in equal parts and let it culture together for about 14 days. Now you have a living soil inoculant specifically adapted to your land. This is the critical distinction from store-bought beneficial microbe products. Those are lab-grown, generic organisms that often cannot survive in specific soil conditions. IMOs are native to your area, and they have evolved to thrive there. But Korean natural farming is not just indigenous microorganisms. It is a complete system of fermented inputs that replace every category of synthetic product. Fermented plant juice is made from young, vigorous weeds, such as purslane or comfrey, fermented with brown sugar. It provides growth hormones, enzymes, and micronutrients and replaces foliar fertilizers, fish. Amino acids are made from fish scraps fermented with brown sugar. This nitrogen-rich liquid replaces synthetic nitrogen fertilizer during vegetative growth. Oriental Herbal Nutrients use angelica, cinnamon, licorice, garlic, and ginger, fermented first in rice wine and then in alcohol. They act as a natural pesticide and a plant immune booster. The fermented material can be reused up to 5 times. Water-soluble calcium is made from eggshells roasted and dissolved in brown rice vinegar, providing bioavailable calcium for flowering and fruiting. Water-soluble calcium. Phosphate uses charred bones dissolved in brown rice vinegar for calcium and phosphorus during fruit set. Lactic acid bacteria are cultured from rice wash water and raw milk, improving soil ventilation and suppressing pathogens. Bacteria improve soil health and plant resilience. Biochar, porous charcoal, serves as housing for microorganisms and retains nutrients and water. Biochar helps keep those microbes and nutrients available to plants. Every single one of these can be made from waste products, kitchen scraps, fish guts, eggshells, weeds, rice wash water. The total cost is essentially zero compared to hundreds or thousands of dollars in synthetic inputs per acre per year. The research backs this up. University of Hawaii researcher Alyssa Kelikuli in 2018 and 2019 isolated and identified bacteria from soils treated with Korean natural farming, confirming significantly higher populations of phosphorus solubilizing and nitrogen-fixing bacteria compared to conventional soils. Kelikuli and Wang demonstrated that these soils maintained fertility without synthetic inputs. Liao and colleagues in 2019 compared long-term natural farming versus conventional farming on cabbage fields in Japan, showing natural farming improved soil organic matter, nutrient availability, and microbial diversity at multiple soil depths. Kumar and Gopal in 2015 published a comprehensive review in 3 Biotech, cited 222 times, confirming that indigenous microorganisms improve soil structure, plant health, nutrient cycling, and waste decomposition across multiple crop systems in over 30 countries. Sulak and colleagues in 2018 demonstrated that natural farming practices improved soil quality and crop health in black pepper cultivation in Malaysia. Bai and colleagues in 2020 showed the opposite, finding that long-term chemical fertilizer use reduces both bacterial and fungal diversity by altering soil chemical properties, limiting ecosystem functioning. Hartman and Six in 2023 published a major review in Nature Review's Earth and Environment, cited over 1,000 times, confirming that intensive soil management and chemical fertilizers damage soil structure and reduce microbial diversity, and that arbuscular mycorrhizal fungi are critical for nutrient uptake and soil health. An honest caveat here. While the science supporting the mechanisms behind Korean natural farming is strong, the evidence specifically on the complete system is still relatively limited. More large-scale controlled comparative studies are needed. So why have most people never heard of this? The global synthetic fertilizer market is valued at over $200 billion annually, dominated by a small number of massive corporations including Nutrien, Yara International, the Mosaic Company, CF Industries, and OCP Group. Research by Hernandez and Terrero in 2013, published in Agricultural Economics, documented that the fertilizer industry operates as a highly concentrated global market where pricing behavior suggests oligopolistic conditions. A few companies control supply and pricing. The business model depends on repeat dependency. Synthetic fertilizers provide a quick nutrient hit but degrade soil biology over time, meaning farmers need more fertilizer each year, not less. Phosphorus fertilizers specifically are documented to reduce mycorrhizal fungi populations, according to Pahalvi and colleagues in 2021, a study cited over 1,000 times. When you kill the fungi that help plants access nutrients naturally, the plant becomes entirely dependent on the synthetic version. Herbicides and pesticides further reduce soil microorganism populations, according to Mina and colleagues in 2020, cited 825 times, creating a vicious cycle where chemical inputs kill the biology. The dead biology cannot feed the plant, so you need more chemical inputs. This is not a conspiracy, it is a business model. The industry is not hiding Korean natural farming. They simply have no incentive to fund, publicize, or validate a method that costs nothing and would eliminate their customer base. The entire research and extension apparatus of modern agriculture is oriented toward input-based solutions because that is where the funding comes from. University extension programs are often funded by the same companies selling the products. Korean natural farming, which uses free local materials, does not have a corporate sponsor to fund massive trials. If you want to start, here is what you do. Find the nearest undisturbed wooded area with rich leaf litter. That is where the IMOs live. Start with IMO 1. Cook plain rice, box it up, and bury it in the leaf litter for 3 to 5 days. Look for white mycelium, not green or black mold. Make IMO 2 by mixing the rice with brown sugar at equal weight and store it in a ceramic or glass jar at room temperature. Make lactic acid bacteria by saving rice wash water, fermenting it for a week, then adding raw milk at a 10:1 ratio, fermenting again, skimming, and adding brown sugar. Make fermented plant juice by harvesting young, vigorous weeds early in the morning after a dry day, chopping and layering them with brown sugar, and fermenting for 7 to 10 days. When you are ready for field-scale application, scale up to IMO 3 and IMO 4. Most Korean natural farming inputs are diluted at ratios of 500 to 1 up to 1,000 to 1 with dechlorinated water before application. Ideal fermentation temperature is 23 to 25 degrees Celsius. Master Cho spent 60 years perfecting and freely sharing this system. He traveled to over 30 countries, never patented it, and never turned it into a corporation. He passed away in 2025, but the knowledge lives on in every farmer he taught. The science says soil is alive. It is the most complex ecosystem on Earth, and for the last 80 years we have been treating it like a dead chemical substrate. Korean natural farming will not replace industrial agriculture overnight, but for home gardeners, small farmers, and anyone looking to break free from the fertilizer treadmill, this ancient Korean soil trick is real, it is free, and it works. The knowledge is not lost, it is waiting in the soil. You do not need permission to stop buying fertilizer. You do not need a corporation to validate what centuries of Korean tradition and decades of modern research already confirm. The question is not whether this works. The question is why it took this long to hear about it.